Games need good enemies. Bad enemies make games boring. They feel fake and unresponsive. Players stop having fun when their opponents are predictable and unintelligent. The problem is clear. We need enemies that can find the player, then chase them, then attack in a smart way. This essay shows a simple plan to make that happen in Godot. We will build an enemy that feels alive. It will react to the player's presence. It will hunt them down. It will create a fun and engaging challenge. This is the core of good game design. The solution starts with clear roles. The enemy must first see the player. Then, it needs to move toward the player. After that, it must try to hit the player. Finally, it should return to its normal routine if the player runs away. We can build this entire system using nodes that Godot provides. Detection is the first and most critical step. This is how the enemy becomes aware of the player. The simplest method is to use an Area 2D node. Add it as a child of your enemy scene in the scene tree. Give it a collision shape 2D, like a circle, and set its radius to define detection distance. When the player's character body enters this area, the Area 2D emits a body-entered signal. We can connect our code to this signal. This will trigger the enemy to start its chase logic. It's a simple and efficient way to know when the player is nearby. However, just being nearby is not always enough. A wall might be between the enemy and the player. The enemy should not be able to see through walls. This is where a raycast 2D node becomes useful. When the Area 2D detects the player, we can activate a raycast 2D. We point this raycast from the enemy toward the player's position. The raycast checks if there are any obstacles, like walls, in the way. If the first thing the ray hits is the player, then we have a clear line of sight. If it hits a wall first, the enemy should ignore the player and continue its patrol. For a more advanced and realistic feel, you can create a vision cone. A simple vision cone can be made with 2 or more raycast 2D nodes, angled outwards from the enemy's facing direction. You can also use code to check the angle between the enemy's forward direction and the direction to the player. Once the enemy detects the player, the chase begins. For simple, open levels, the enemy can just move in a straight line toward the player. You can get the player's position and calculate a direction vector. You normalize this vector and multiply it by the enemy's speed. Then you use the move and slide function on the character body 2D to handle the movement. This direct approach is fast and works well when there are no obstacles. It creates an aggressive, relentless pursuit that can be very effective in certain game designs. However, most game levels have walls, pits, and other obstacles. A simple-minded enemy would just run into a wall and get stuck. To make the enemy smarter, we need pathfinding. Godot provides a powerful navigation 2D node for this purpose. You add a navigation polygon instance as a child of navigation 2D, and draw a polygon over all the walkable areas of your level. This creates a nav mesh that tells the AI where it can and cannot go. You call the getSimplePath function, providing the enemy's current position and the player's position as arguments. When the enemy finally closes the distance on the player, it needs to attack. We define an attack range, a short radius around the enemy. In the chase state, we constantly check the distance to the player. If the distance is less than our attack range, transition to the attack state. In the attack state, we stop the enemy's movement. Play an attack animation via Animation Player. This gives the player visual feedback, a chance to dodge or block. Don't apply damage the instant the animation starts. Time the damage to match the animation. Add a call method track to the attack animation. Visual. Show timeline with a keyframe labeled deal damage on the method track. Call the damage function at the exact weapon swing frame. Alternatively, start a short timer when the attack begins. When the timer finishes, apply the damage. This keeps the visual and hit timing in sync. To prevent spamming, add an attack cooldown. After attacking, the enemy can attack again for a short period. Use another timer for the attack cooldown. When the attack finishes, start the cooldown timer. Only allow transition back to attack if the cooldown timer is not running. This creates combat rhythm, so a window to counterattack. Now that you have all the pieces, it is time to test and refine your enemy. The first step is to simply play your game scene. Watch how the enemy behaves. Does it detect you correctly? Does it get stuck on walls? Is the attack too fast or too slow? Act like a real player. Try to run from the enemy. Try to hide behind objects. Try to trick its AI. These initial playtests will immediately reveal the most obvious bugs and areas for improvement. Do not be afraid to see it fail. Every failure is a clue to making it better. Next, create a quick checklist of values to tweak. Move. Shut speed, detection, Jakcha radius, area 2D, attack range, attack, Jakcha damage attack, Jakcha cooldown, timer. Change one value at a time, then playtest again. Small changes to these numbers can dramatically alter the feel of the game.